for all the sections of class 9, and the chapter number is 2. So in your previous classes, that means in your lower standard, you have studied about chemical and physical changes. So let's begin. What is chemical change or chemical reaction? So you have learned chemical changes are those changes in which the new substances are formed with new sets of properties. Okay, let me repeat it once again. Chemical changes are those changes where new substances are formed with new sets of properties. So in a chemical change, or in chemical reaction, what happens? New substances are formed, okay, with new sets of properties. That means the previous 4 bonds are broken in the reactant side, and in the product side new bonds are formed. So let's discuss the most common example, okay, that we see in our daily life, the formation of water molecule. So here is an example. Let's discuss chemical change with an example. Hydrogen reacting with oxygen to give water molecule. So hydrogen, you know, it is a gas. Oxygen is also a gas. These two are reacting, and this is your product, and this product is liquid. Now see, before the reaction, this hydrogen is what? It's a gas, which is a combustible gas, and you must be knowing this is used as fuel in rockets. So it must be having a very high calorific value. Oxygen is also a gas, and it is a supporter of combustion. So before the reaction, this has a different property, its own set of properties, and oxygen has its own set of property. Now after the reaction, these two have combined together to form water molecule. And water is what? It's in liquid state. Means a new property has been generated. And the other thing that you can see is these two are what? These two cause fire. They cause fire, or they burn. But after the reaction, this water is what? It's a fire. It acts as what? Fire extinguisher. So please, with this example, you come to know what? You come to know that before the reaction, they have different set of property, and after the reaction, a new compound is formed, which has different properties than the reactant. So by this example, we can explain what is a chemical change. Okay? Similarly, let's take another example. Let's take nitrogen plus oxygen. This is N2, nitrogen gas, which is found in atmosphere, and this is oxygen gas, which is also found in atmosphere. Now during thundering, what happens? At a very high temperature, a new type of compound will be formed. So here here what we have? We have lightning. Okay, that usually happens these days. The thunder. What happens? This nitrogen is present in atmosphere. Oxygen gas is also present in atmosphere. Now during after lightning, what happens? You can see there is a bond formation between this nitrogen and oxygen, and here also the bond is formed between nitrogen and oxygen. So what has happened after lightning? These two bonds they have cleaved, means they have broken, means here we have breaking of the bond before breaking of bonds, and here we have formation of new bonds. Here the bond is between nitrogen and nitrogen. Here the bond is between oxygen and oxygen. But here after the reaction, this bond formation takes place between nitrogen and oxygen. Okay, similarly here also nitrogen and oxygen. And this compound NO is known as nitric oxide. So what's the difference? The difference here, see, on your left hand side you have 2 atoms of nitrogen, 2 atoms of oxygen. On the right hand side also you have 2 atoms of nitrogen, 2 atoms of oxygen. The difference lies in breaking of the bond. Here the bond has broken, and here new set of bond has been formed between nitrogen and oxygen. So we can conclude that a chemical change, in a chemical change, what happens? No new atoms or element is formed. Okay? What happens? Actually, this arrangement of the bond takes place. Actually, what happens? Arrangement of bond takes place. Hope this is clear. You see, you have 2 atoms of nitrogen before the reaction. After the reaction also you have 2 atoms of nitrogen. That means no new element, no new atom or element is formed. Yes or no? And the second point, actually arrangement of bond takes place. That means here before the reaction you have a bond between nitrogen and nitrogen, but after the reaction you have a bond between nitrogen and oxygen. So the bonding arrangement has taken place in a chemical reaction. Now let's discuss what are the conditions for chemical reaction to take place. The second point for today's discussion is condition for chemical reaction. So, number 1 is close contact or mixing. Suppose you have 2 elements, say A and B. So you have what? 2 elements, and what you did? you just kept A and B separately, say on a table or on the floor. Will the reaction take place? No. Why? Because for chemical reaction to take place, there are certain conditions which has to be fulfilled. The first one is close contact or mixing. So for this reaction to take place between A and B, first of all, they have to be brought together. They have to be brought close enough so that they can come in contact with each other. Then only the reaction will take place. Okay? So first point is close contact. The second one is solution. Now there are certain reactions which take place only in solution state. That means they have to be brought to the liquid state, then only the reaction will take place. Okay? So let's take such example. Say common salt, table salt, NaCl. Whenever it reacts with AgNO3, silver nitrate, solution. Please look at this. Solution means they have to be in aqueous state. Both of this has to be in aqueous state. Then only this reaction will take place. If you take salt, the solid salt, and put it in AgNO3, which is in aqueous solution, then the reaction will not take place. Okay, please remember this. This NaCl, it has to be first dissolved in water, then put it to silver nitrate. Then what will happen? Then only the reaction will take place. Now here also the breaking of the bond and the formation of new bonds will take place. Here the product will be AgCl. Okay? AgCl plus NaNO3. And this is the precipitate, and it is white curdy precipitate. So this reaction takes place only in solution state, that is in the liquid state. Now there are other conditions as well. This first one is they have to be mixed. The second one, they have to be in the solution state or in the liquid state. The third one is some of the reaction. Hope you have noted down this one. The third reaction, the third condition for a chemical reaction to take place is heat. Okay? Now there are certain compounds or certain reactions which are very stable, and until and unless you hit them, the reaction doesn't take place. For example, copper carbonate. Now this copper carbonate, okay, if it is heated, this sign is for heating. Is heated, and then only this reaction will take place, where the product formed will be copper oxide and carbon dioxide gas will be evolved. Now, if you don't heat it, then will this reaction take place? Not at all. This reaction will not take place if it is not heated. Okay? Because it is very stable. Once you heat it, what will happen? Then only the reaction will take place. Similarly, the fourth condition is presence of light. LIGHT. The most common example, photosynthesis. Okay? this. Now, you know, for photosynthesis to take place, by which photosynthesis is the process by which plants they prepare their own food. Now, what are the requirements? They need carbon dioxide, they need water, and also sunlight. Please note this, sunlight. Then only glucose will be formed. If sunlight is absent, then this reaction won't take place. So there are certain reactions where light is very, very mandatory. So let's write photosynthesis reaction. Carbon dioxide reacting with water to produce glucose, C6H12O6. And here what is required? Sunlight. Okay, please note it down. If sunlight is absent, this reaction won't take place. Okay. Now, 4 conditions we have already discussed. The 5th one is electricity. Now, there is certain reaction, okay, which require electricity if it has to occur. For example, water. Now, if you want water to be converted back to its components, that is hydrogen and oxygen, how can you do it? You can do it. See, if you want water to be converted back to H2 and O2, out of which water molecule is formed. Is it possible? Just like that? No. You took the water on a cup and you want them to be converted to hydrogen gas and oxygen gas. You just get it. Is that possible? Not at all. If you want to convert water molecule to hydrogen and oxygen, then you need to supply what? Electricity. Okay? Electric current is must for such reactions. So 5 conditions we have discussed. Now let's discuss. Now this balancing I have already taught you in class. So here our main focus will be on discussing the conditions. Okay, balancing I have already taught you. Please, while writing this equation in your notebook, please write them in balanced form. So here I will be doing it for you. Here we have 2 oxygen. Now here 2 oxygen, 2 to 4 hydrogen. Here we have 2 hydrogen. Here if I write 2 in front of this hydrogen, then it becomes 4 hydrogen. Now this equation is balanced. The 6th condition. Let's discuss about the 6th condition. The 6th condition is presence of pressure. Now, here we will be discussing about your favorite gas. Your favorite gas is what? You can predict it. Ammonia. Okay? Now, if you want to prepare ammonia from nitrogen and hydrogen, this is ammonia. And what you want to do? You want to prepare ammonia, your favorite gas, ammonia, from nitrogen and hydrogen. Then, until and unless you apply some pressure over there, until and unless some pressure is applied, this reaction is not going to take place. Now, if you just keep nitrogen and hydrogen like this, will this ammonia be formed? No. But this is formed, ammonia is formed when you apply pressure around 200 atmosphere. How many? 200 atm. This is atmosphere. Unit of pressure, 200 atmosphere. So when nitrogen and hydrogen is compressed under this pressure, that is 200 atmosphere, then only formation of ammonia takes place. Okay? Now this is the sixth condition. Some reaction can take place only under certain pressure. The seventh condition is catalyst. What is a catalyst? So let's discuss that first. Catalysts are those substances, okay, which either increases or decreases the rate of chemical reaction. In simple words, either it speeds up the rate of chemical reaction, means it speeds up the formation of product, or it retards the rate of formation of product. So let's discuss this. We are discussing about decomposition of hydrogen peroxide. This is hydrogen peroxide. Now you want to decompose it to what? You want it to decompose to water and oxygen. Okay? So if you want to balance it, write 2 here, 2. 4 hydrogen, 4 oxygen. Here we have 2 oxygen plus 2 oxygen is 4. So now if you want to increase the rate of this reaction, means if you want to speed up this reaction, then what you have to add? You need to add manganese